Hi. Okay, so we now starting with the basic networking. So firmware is upgraded with the 12.1. Here you can see. Okay, so in this scenario, we have a network interfaces. You can see we have two interfaces, 1/1 and 1/2 is network interfaces. Okay, 0/1 and 1/1. Okay, so we want that 1/1, okay, it should be associated with front end network. Okay, whatever the front end of our virtual IPs, okay, will hit it will hit through 1/1. Okay, and my backend servers and my management network belongs to 0/1. Okay, so we have three different networks, one for management, which is 1 into 168.10, belongs to 1 into 168.10. I have a front end network that belongs to 172.21.10.0/24, and backend servers, that is 1 into 168.30. So we want to segregate this 1/1 and 0/1 into two different VLANs. Okay, so by default it's a native VLAN. It is VLAN 1. You can see here in the VLANs. So everything is by default is a VLAN ID 1. So all the interfaces in VLAN 1 only. Okay, so we want to configure a VLANs, and 1/1 we need to put into different VLAN, okay, which is VLAN 2. Okay, so to do that, go to the first we need to add IP. So that particular IP needs to bind with that particular VLAN ID, right? So here we have only management interface VLAN, right? So Netscaler IP, and this is a subnet IP which you are using here. So this is belongs to only management. So we want to add a front end VLAN IP here. Okay, so that is 172.21.10.101 net mask 255.255.255.0. Okay, this IP is belongs to virtual IP. Okay, because we are going to use this IP as a virtual server. Okay, so everything apart from this, everything is good. Okay, we don't want anything management access, right? Because this is my data. We don't want to enable management access on that IP. So just create. So this is virtual IP. This is 171. So this is my front end. This is my management, and back end is a, so it's a backend network. We don't need to configure here anything because we are not putting that into VLAN because that backend IP is not directly connected here. Okay, so that is connected after my gateway 1 into 168.10.254. Okay, so let's connect the VLANs. Okay, we want to add a VLAN ID 2. Okay, so alias name we can just configure anything, whatever the name you want. Okay, so which port and which IP to put. So 1/1 should be belongs to VLAN 2, and IP binding which IP. So this subnet, this network, okay, should belong to the VLAN 2. Okay, so create. See now VLAN 2 1/1. Okay, this is now belongs to front end network. Okay, and that subnet is we already map 172.21. Okay, so now we will configure MBF, MAC based forwarding. Okay, so MBF configure system settings, configure modes. Okay, so which mode you are configuring, that matters. So there are edge configuration, layer 3 mode, IP forwarding is already there. Okay, we want to configure MAC based forwarding also, MBF. So MBF is feature once enabled. So uh, this use case of this, if you have a two different ISPs, okay, which is directly connecting to your ADC, okay, so in that case, if you want ISP1 and ISP2, if both are uh, from both the ISPs, if you are getting a traffic, then we want a symmetric routing, okay, symmetric return, okay, to that particular to that associated ISP's traffic, right? So if ISP, if someone sending a traffic from ISP1, then my reply should go through the ISP1 only. Okay, and someone sending a traffic from ISP2 requesting from ISP2, then my return traffic should go via ISP2. But in case of routing, we need to add a route to particular ISP only. Okay, so in that case, a symmetric routing maybe happen, right? So to avoid that, we can configure MPF MAC base. So based on the MAC only, because MAC is unique, right? So ISP1, that router interface, okay, that MAC, if I'm getting a request from that particular MAC, I will reply to that MAC only. It is not based on IP, okay? So based on the MAC, we we can do a reverse route, right? So traffic will return based on the MAC. Okay, so request comes from that receive from which MAC address is just recognized. Okay, and based on that, it just return the traffic on the same MAC address. Okay, so now we'll check the connectivity to the backend servers. So whether my backend servers are reachable. So we have one backend server reachable now, which is 192.168.30.51. So we can just ping it from the follow. So 192.168.30.51. Let's see, count 3 is enough, and we can just ping run. Let's see if we get any reply. Okay, so it is reachable, then backend server connectivity is fine. Okay, so now the next step is configuring a high availability. We have second ADC also, that IP is 192.168.10.102 ns root ns root. Okay, now we are going to configure high availability between these two ADCs. Okay, so before configuring ADC, so whatever the configuration, suppose if the ADC 001, I want to make a primary, okay, and ADC 002 as a secondary, that subnet IP address, that is not required in case of configuring HA, because whatever the configuration available on the primary, it will get automatically sync with the secondary. So no need to care about this. It is okay, but here's the one thing on. So need to go on system high availability and nodes. This is 102. Okay, so main thing we need to do in HA, the one who wants to make as a secondary, okay, or passive, first make sure it is stay in a secondary. Okay, remain in listen mode. Okay, that is the main thing. Okay, because if we configure something wrong, then this configuration will get sync with the primary, and everything whatever we configured on this primary ADC, uh, that configuration will get erased. Okay, and it will get override with this ADC configuration where nothing is configured. Okay, so here you're going to stay secondary. Okay, now go to the primary system, high availability nodes. Okay, so this is 101. This is already the primary showing. It's a default. Okay, so we want to add a node. Okay, so add a node 192.168.10.102. So this is the my neighbor IP. This is okay 102, and the credentials ns root. Okay, just create. Okay, now we have added the configuration, right? This is a primary, this is a secondary. Okay, now what? The secondary, whatever the secondary we have configured, okay, and the node status showing only up, but this is showing only say secondary. That configuration is not getting sync, right? We need to refresh here. Okay, now see that configuration is applied here. Okay, whatever the configure because it's a secondary, it was in a listen mode. Okay, if you want to see uh, anything like IP address, okay, which we added a default route over there, right, in a network. So let's see in system network, you can find three IP addresses. There are four routes are showing. So let's see, there is default route. See, the default route is added. That VLAN which we configured, these VLANs also showing the VLAN 2 is also configured. Okay, so it means configuration got sync. Okay, means that primary ADC's configuration got sync with the this ADC, but this ADC is now not participated in high availability if my primary ADC fails, because it's manually configured as stay secondary only, so it will always remain secondary. Okay, so that is not the use case, so we need to enable it and actively participate in HA. Now let's see, both the nodes are up. It's HA status is secondary and this is primary. Okay, let's save the configuration. Yes. Okay, now we can do the failover here. Just say force failover. Yes. Now see, this was previously primary. Now let's see. This is become now secondary. Okay, and this become this is secondary. Just refresh. See, it is primary again. Okay, now again, if you want to failover, just do the failover again. Force failover. Yes. Okay, now it is showing the primary only, but see, by refreshing it is secondary. Go here, just refresh it again. Now see, it is primary. So this is how the HA configuration done. Okay, now what we want to enable features, right? And very basic features, you need to enable settings. Let's see whether features are enabled. Content switching, SSL load balancing, rewrite. Okay, so these features are enabled, so no issues. So these features are enabled. So Now the second task to manage the HA. Okay, so every time we need to, 10.10 is a primer and a primary phase, then we need to access the ADC with the 102. Okay, so but that is not the mm, proper uh, uh, way to access HA device, right? So if you want to access the HA device, then there should be virtual IP between them, right? So how we can access that? Okay, so we can access with virtual IP. The virtual IP can be used as an IP because SNIP is sync between both the devices, not the virtual IP means that front end, not that IP. We will use the subnet IP. Okay, so for that we will add new IP that 192.168.10.103. This is subnet IP. Okay, but that subnet IP we want to permit access, so enable management access, allow access to management applications. Okay, we don't want telnet and FTP for that, right? So create. So this is the same IP we can use. Oh, sorry, net mask is not added. 255.255.255.0. Okay, create. Okay, so 192.168.10.103. So now if you want to access 192.168.10.103 with this IP, we can access the same HA parameter. So we no need to care about whether that device is primary or secondary. So always we are going to log in a primary device only. This is ADC1 or ADC2. We no need to care. Okay. So have availability we already configured, and 10.103 is an IP we can add. So next we can configure. Okay, we do the load balancing now. Okay, okay, so load balancing. So load balancing starts with adding a servers first, right? Because without server we can't create a services, right? So first the LB feature is already enabled. That features enabled, so you can see if there is no any yellow mark, it means feature is already enabled. Okay, so first we will add a servers. So go to the load balancing, servers. Okay, to add a server read srv read IP address 192.168.30.51. It's IP of the server. That's good. It's added. Now server blue. Server blue. What's IP address of server blue? It's 30.52. Let's see. Yeah, it is added. Now add server green. There are three servers, right? Server green 30.53. That's good. Okay. Now we have added a servers only, right? But to create a virtual servers, we need a services. Okay. To add a services, you need to create a services. So service name, service raid. We have already added exit server, service raid, protocol 8, port number 80, right? That's good. Protocol done. So the service is up on port number 80. Okay. Now we have two more services. That service blue. Okay. We have existing server for that. Service blue. That's okay. Done. Now we have one more service, that is service green. Service green, existing server, service green to quality. That's okay. Done. Service green also added. Okay, so we have added a services. Now we will create a basic load balancing. So just create a virtual server, add, give a name to the virtual server. What is it? LB VSRV server RBG, red, blue, green. Okay, protocol 80. So the front end IP, right? So virtual IP 121.10.101. So front end IP you going to provide here. Okay, now just add service bind. So which service we are going to bind? Just which you added three services, which is three services only available right now. So we add all the three services. Select, bind, continue. Okay, so we have added a three services, but what's the method? Load balancing method. We can just method. We want a round robin. Okay, so this is round robin method we are applied for that. Okay, so this is up now. Okay, now we want to test whether it working as load balancing in a round robin fashion. So let's see, TP 172.21.10.101 slash home.php. See, it's blue, green, red. So it is working. Okay, yeah, time is available. Okay, so it is getting load balance. Okay, in a round robin fashion. You can check its statistics here. Let's see, statistics. We got the hits here, and here are all the three server statistics. We are getting responses and hits. Let's see the hits. It's a same numbers. Okay, so we are getting that. So it's a round robin fashion. Okay, but there's a requirement we don't want in a round robin. Okay, if you connect in a server, okay, then it should connect that servers for that time. Okay, so we need a persistence for that. So what persistence? You can see cookie insert. Okay, or you can say just yeah, this type of this. Once it connects, if suppose it connects to red, then it should stick to the red only. Okay, if that is requirement. So let's see. Now again we are a green. Just refresh. Now it is on red, so it should stick on red only. See, if I refresh multiple times, it will be connect on red only. Now if I send a multiple requests on red, so let's see the statistics. There should be higher number hits in red server. Let's see. Let's see on the red we have 118 because it stick to red only. Okay, so this is how cookie insert work. Okay, let's remove cookie insert because in the lab we don't want cookie insert. Okay, cookie insert, just make it again others. Okay, done. Let's see again. Now it will again balance the round robin fashion. See, red server, red, green, blue. Okay, so it's working in round robin fashion. Now the monitors. So these default monitors is only monitoring TCP three-way handshake. okay, which is currently enabled, but we want advanced monitor, right? So, so monitoring for the servers, we just figuring monitor RBG HTTP. We want to monitor HTTP. Okay, so what type of monitor is HTTP? Let's see. Okay, so this is a HTTP type of monitor. Want to here. So in this, it will check whether I'm getting a response code 200 when I'm sending a request head slash. Okay, so this is the one normal HTTP monitoring. Okay, plus, oh, sorry, just a second. Okay, okay, so RBG we are configure plus we want to configure HTTP ECV. So monitor HTTP, get RBG G HTTP ECV. Let's see, type HTTP. This is HTTP ECV. Select that. Okay, what ECV does? Okay, so ECV sends a string, okay, as per your requirement, okay, and check whether we are getting that page, okay, that string, okay, in reply. So we just sending a string, that get slash home.php. This is my page, okay, this is my page available on server home.php, okay, and in return I'm expecting uh, server info server info in body. Okay, if you see, if I am sending that home.php, here is a server info in a body. Okay, so if I'm sending a request to slash home.php and if I'm getting a server.info in any body, okay, so it means it's up and its service is working. Okay, so that's a proper response I'm getting. So just create, okay, so HTTP ECV. Okay, so let's configure these two services to my, so monitors needs to apply under services only, right? Because services who monitors the backend uh, backend services. Okay, so RAID, we are going to apply the monitor for a RAID. See, is a monitor service, load balancing service, monitor binding. So default is TCP, three-way handshake. So success TCP seen ACK receive. You just send 10 line out port number like that and it's getting seen ACK. Okay, but that is not the proper monitoring, right? So we want to monitor proper way. Okay, so we have a name like MON. Let's see. Okay, so this is one we have created. Monitor RBG monitor. Select bind. See, now success HTTP response code 200 received. So this is the advanced monitoring we have created. So now which is monitoring properly. It is HTTP based, application based. It is monitoring, right? Okay, for server blue for testing we are just applying. So here we will apply another monitor, that is HTTP ECV is monitor, see HTTP ECV RBG HTTP ECV, select bind. See, here is showing success pattern found in response. What was the pattern? If I'm sending a slash home.php, then I should receive the server info in a body. So it's saying that yeah, I'm getting that. So this is a more efficient way we can monitor, right? So done. See, till it is up. Okay, we can use any method, but ECV is better monitoring way. So we can see we are getting a proper response. Okay, now ooh, sorry. Statistics we already check. Now we do the load balance with the DNS. Okay, so we go to service group. Okay, in service group we will create a group for a domain, service group domain. So service group domain DNS. So DNS servers we are going to monitor. So this is protocol DNS, right? Okay. So what I have, that is okay. Okay. No service group member is there, so we are going to add service group member. So IP base 192.168.30.11, port number 53. Create. Again, one more server we are going to add, 192.168, 168.30.12, port number 53. Create, close. Okay, so we have created service group. Just enable, done. See, now it is up. So service group for DNS, it's up. Now we will create a virtual server for them. So just create load balancing virtual server LB VSRV DNS protocol TCP, sorry, DNS, right? DNS IP address. So we will give a IP address from virtual IP, that is 121.10.102.53. It is okay. Now service, we have created a service group for them, not service, right? You have service group. Which service group? That is only one service group available right now, which is service domain DNS. Select, bind, and here we are going to continue. Okay, here also method we are going to add. This is round robin. Okay, done. Now see, this is up. So for domain also we need to create a monitors, right? Yes, 20 minutes. Okay. For domain, how we can monitor a domain? This is not only related to the port number or service. The domain monitoring should be based the one who can resolve. Okay, if it is resolving with a particular IP, then that server is up and is functioning properly, right? So we need to monitor accordingly. Okay, so create a monitor DNS. Type of monitoring is DNS. So DNS. Okay, so interval 5, just we need to send a query. Okay, so any which is available on the DNS server. So server, there is a one query is available, nyc dash web dash red dot workspacelab.com, workspacelab.com. Okay, so this query is available. Okay, and the address we should expect that 192.168.30.51. If this address, if we are get in this query, then it means that server is functioning properly as a DNS server, right? So we create, let's see, monitor DNS, it is enabled. Okay, let's bind it under service group. So we have a service group, right? Let's open monitor. In the monitor, where is, where is that monitor? Here, service group monitor binding. So there is no by default monitoring anything. So let's type a name. Name is MON monitoring DNS. Select it. Select bind. Okay, done. See, it is bind here. Let's check the status of the servers. It is up. Means okay. So to check that, to verify, we monitor details. Okay, how we can see that? Go to the service group. Go to the open that service group and open that monitor. Service group monitor is so individually it will show the monitor status is up. Okay, so it is resolving. So problem done. Okay. Now we'll do a load balance. So Ldap. Okay, so we have Ldap servers. Okay, so first we'll create load balancing service group. Okay, basic settings. So go to the service group first. Service group, add service group svcg domain Ldap. Okay, the protocol which you are to use is a TCP because we don't have protocol like Ldap here, so we're just mentioning protocol TCP. Okay, and okay, now service group member we just add. So what's the IP address? 192.168.30.11. Port number for Ldap is 389. Create. One more group member. 192.168.30. 168.30.12. Port number 389. Create. Close. Okay. Done. Let's see, it is up. No problem. Now we will create a Ldap virtual server. So go to the virtual server, add, give it a name, LB VSRV Ldap. Right. Again, protocol, TCP, IP address from 172.21.10.103, port number 389. Right. Click OK. Now we have created service group for that. So just bind that service group, which is Ldap. Select bind. Okay, so load balancing method here also we want a round robin, right? So create a method. So list connection, create it to round robin. Okay, okay, done. Now again we want advanced monitor, okay, or to monitor that properly. So how we can monitor LDAP servers? uh, to monitor the LDAP servers, then it should authenticate, right? It should authenticate properly with the host name, the domain name user, okay, and it should get authenticate, okay. If authentication is successful, then it means that LDAP server is up and running, working fine. Okay, so give a name, monitor LDAP, like type LDAP, LDAP monitoring. See, this is LDAP. Select. Okay, so this is a defined interval. So what is the password we are going to use here? This is password 1, PASSWORD, password 1, base DN. Okay, so base DN is DC equal to workspacelab.com. Okay, DC equal to COM. Bind DN is TRAIN, train AD user at the rate workspacelab.com. Is filter is CN equal to built-in BUILDIN. Built-in attribute is member of. Okay, this is what we're going to configure. Okay, that's an advanced parameters. Click on that and select the script, that is nsd nsldap.pl, nsldap.pl, that is that. Okay, so everything is configured, so just create. Let's see, monitoring LDAP is now configured. So if it is configured, then we can just go traffic management service group and just bind that monitor. So monitoring, there is no default service group. Monitoring, just go name MON monitoring LDAP, right? Select, bind, done. Let's see, still it is working, right? So if you check at the binding how it is working, just go click on service binding and see state is up. It is uh, getting authenticate properly. Okay. Oh, this is failed. Select. See, it's just failed. Something is wrong. Service Ldap, monitor bind. Okay, let's see what is the problem over here. Ah, it's binding mon Ldap. Done. It is down. Go to again monitor. So it is not working. Monitor Ldap. Let's see if everything is correct. Okay, DC workspace lab.com, DC equal to com, bind train AD user at the rate workspacelab.com. Cn equal to built-in, builtin, built-in is right. Member of is also right. Password, if you see the password, you can just add again. PASSWORD, password 1. Okay, let's see. In advanced parameters, it's already there. Script is there in advanced parameters, that is also right. NSLB, power enable. Okay, let's see again. Service group, refresh. Oh, it is not up. It's not coming up. Why? Type, monitoring type, Ldap. Okay, let's remove the monitoring. Done. And refresh. Oh, even removing the monitoring also is not coming up. Then just a second. Let's monitoring. We just need to remove it like that. Yes. Close. Done. It is up now. Now something is wrong with the monitor. Oh, what's the time? Okay, let's see why Ldap is not getting monitored properly. Let's see. Name MON monitoring Ldap. Enable type Ldap, right? That is okay. DC something is wrong. DC equal to workspace lab.com comma DC equal to workspace lab, right? Train bindian train AD user ADU in caps at workspace lab.com. Everything is right. Okay. Cn built-in, Cn equal to built-in, that is also right in a filter. Member of member of an attribute field, that is also right. Then what is the problem? Let's see. NS Ldap is also right. NS Ldap dot pl. Everything is right. Destination IP, dispatcher IP, that is not right. Everything seems fine. Nothing is wrong with it. That's still that LDAP monitor not working, right? Configured state is enabled. Okay, but still it's not coming up. I need to check. If I bind to again service group, we are binding the proper way. LDAP TCP service group members. We need to bind it. Service group. LDAP to bind monitor again. Let's see. Name MON monitor Ldap. Select bind done. Let's see. Something is wrong with that. The monitor, maybe remote credentials or not. Okay, let's see the server. That ADC server, it is a dependency ADC 003 that is to enable in a backend. No, it should work. I don't know what is the dependency with this server. Okay, it's okay if it's because it was working, but right now if it is not working, maybe configuration wise is okay because there is a backend servers that Ldap servers need to work. It's okay, no problem. Well, for time being, we just remove this binding. There is some backend server issue maybe because it should get authenticate properly. That's why. Okay, no problem. So, okay. So this is how virtual servers and load balancing works. Okay, it's my time is getting close. Okay, so thank you and just do the recording.